video, I'm going to be solving systems of nonlinear equations in two variables. Let's start by solving with the method of substitution. Okay. Now, on this system of equations, we're going to solve it by the substitution method. Now, the first step of substitution is that you need to have one equation solved for one of the two variables. So in this case, we already have that the y is being solved. So y is equal to x squared minus 7x plus 10. So what I am going to do is substitute this expression into the y of the top equation, because that's what the y is equal to. So my first equation is going to look like x plus y equals to 2, but the y is going to become x squared minus 7x plus 10. Then the next thing we're supposed to do is we're going to combine like terms, which is this one and this one, right? So x plus minus 7x is negative 6x. So then I'm going to bring everything else. So it's x squared minus 6x plus 10 equals to 2. In order to solve this equation, we need to factor. So first of all, we need to equal it to 0. So we're going to move the 2 over to the other side, as usual. So it's going to give us x squared minus 6x plus 8 equals to 0. And then we can factor this. Two numbers that multiply give me 8. And when added, they give me negative 6. So it's going to be 4 times 2. But both negative, right? So it's going to be x minus 4 and x minus 2. Then we're going to solve for x. So we have here that x is equal to positive 4 and x is equal to positive 2. So these are the values of x for the solutions right here. So then we need to find the value of y for each one. How do we do that? By substituting this value of x into one of the two original equations, right? The first or the second equation. I'm going to be using the first equation. X plus y equals to 2. So it is always recommended that we try to use the simplest equation possible when we're finding the second value. So x is going to be 4 plus y is equal to 2. So then we subtract 4 from both sides. So y equals to negative 2. So when x is equal to 4, y is equal to negative 2. So my first solution is going to be the point 4, comma, negative 2. On this one, now we're going to replace the x with the 2. So it's going to be 2 plus y equals to 2. So if I subtract 2 from both sides, I get y equals to 0. So when x is equal to 2, y is equal to 0. So the next solution is 2, comma, 0. So that means that these two graphs, the graphs of these two equations intersect at the point 4, comma, negative 2 and 2, comma, 0. And it really makes sense because you see that this is a line and this is a parabola. So a line and a parabola can have 2 points of intersection. Okay. So next problem. We're going to solve a similar one at the end, to this one. So I'm going to skip it right now. Let's solve this problem by substitution. So to solve it by substitution, first we need to isolate one of the two variables. Now, I wouldn't suggest that we isolate any of these two on the top because I would have to divide one to get the other one by itself. And if I do that, we're going to get a fraction. We can work around it, but again, it is going to be a little bit more work. Okay, so the easiest thing for us to do in this problem is that if you see that the bottom y has a coefficient of 1 in the front, so that's going to be the easiest one for me to solve for. So let's go ahead and isolate the y. So I'm just going to move the 3x as a minus 3x to the other side. So it's going to give us negative y equals negative 3x minus 6. And then we divide the negative 1 on both sides to get rid of the negative. So it gives us y equals 3x plus 6. So that's what the y is. So then we're going to replace this value of y into the other equation, into the y of the top equation right here. So then it's going to be, my new equation is going to look like this. Just going to put the arrow pointing this way. So we're going to replace it into the y of the top equation. So my new equation is going to look like x times whatever y is equals to 24, and y is equal to 3x plus 6. So I'm going to replace the 3x plus 6 for the y. Then what do? We're going to distribute right here. So that gives us 3x times x is 3x squared, plus 6 times x is going to be 6x. And that is equal to 24. Once again, we need to factor this. So if to factor, we need to first equal it to 0. So I'm going to subtract the 24 from both sides first. And that gives us the following equation. 3x squared plus 6x minus 24 equals to 0. Then we need to factor. Okay. Now, before we do the AC method, something that we need to consider here is that these three values, they have a greatest common factor. So the first thing is that I'm going to take out the greatest common factor of 3. So if I do that, then my equation is going to be reduced to 3 times x squared is 3x squared, 3 times 2x is going to be 6x, and 3 times negative 8, it's going to be negative 24. Then we're going to factor using the AC method as usual. But now you see that the coefficient of the x squared is a 1, right? So 1 times 8 gives me an 8. We need to find two numbers that multiply to 8, and when we subtract them, they give us a 2. So it's going to be 4 times 2. But it's a positive 2, so it has to be positive 4 and negative 2. Then when we solve for x is equal to negative 4, and x is equal to positive 2. What do we need to do after? Find the values of y for each of these values of x. So we're going to substitute each one of these into one of the two original equations. I'm just going to use the first one. I mean, both of them are simple in this case, so I'm just going to use the first one. X times y equals to 24. We already know that x is negative 4, so negative 4 times y equals to 24. To leave the y by itself, we divide both sides by negative 4. That gives us y equals to negative 6. So that means that when x is equal to negative 4, y is equal to negative 6. The first solution is negative 4, comma, negative 6. Now, for the second solution, we're going to replace the x equals to 2. So the equation is xy equals to 24. So if x is equal to 2, then it's 2 times y equals to 24. And I divide by 2, so to get the y by itself, so y equals to 12. So then when x is equal to 2, y is equal to 12. The second point of intersection is the point 2, comma, 12. So these two equations intersect at the points negative 4, negative 6, and 2, comma, 12. Next. Now we're going to solve a couple of systems by the addition method. Okay, we're going to start with this question here. No, let me see. We're going to see a similar one at the end about to that. Alright, so we're going to solve this system by addition. Okay. Now, to solve it by addition, remember that the first thing in the procedure is that we need to make sure that both equations are in the form ax plus by equals to c, which in this case, both of them are like that, right? Second, in order for us to cancel out the x's or the y's, let's say we're going to cancel out the y's in this one. If I wanted to cancel those y's, I cannot multiply this equation, the 2 times nothing, to give me a 3. So what do I need to do? I'm going to cross multiply them. The 2, I'm going to multiply it on the top equation, and this 3 on the top, I'm going to multiply it on the bottom equation. Do we need a negative? The answer is no, because we already have a plus and a minus. Okay. So then, if I multiply 2 on the top equation, we're going to get an 8x squared 2 times negative 3y squared is negative 6y squared equals 2 times negative 8 is minus 16 or negative 16. Second equation, 3 times 5x squared is 15x squared. 3 times 2y squared is plus 6y squared equals 3 times 13 is 39. Then we're going to add them. 8 plus 15 is 23x squared. The y squares cancel equals negative 16 plus 39 is 23. Then to solve for x, for this one you see that there's only one x. Even though it's a square, we don't need to factor. We can use the square root property because the only term we have is the x squared. Anytime we only have the term that has a square, you can always use the square root property, which is going to be the simplest way to solve it. So for the square root property, first of all, let's isolate the x squared here by dividing the 23. So we get x squared equals to 1. And then the square root property tells you I can get the square root on both sides to get rid of the square here, but it's going to be a plus or minus. So the square root of 1 is going to be positive 1 or negative 1. Now we need to find the values of y. How? By replacing these two values of x in one of the two original equations. Let's go ahead and use the second equation. So if I replace x with the 1 right here, we are going to get 1 squared, which is 1, times the 5 is going to give me a 5. Right? So we get 5 plus 2y squared equals to 13. Then we can also use the square root property, you see, because there's only the one term squared. We only have one y in this equation, so we can use the square root to solve for that. So we're going to move the 5 over, so that gives us 2y squared equals to 13 minus 5 is going to be 8. Then we have to divide both sides by 2 right here. So that gives us 2y y squared. Let me erase the 2y squared equals to 4. Then to get rid of the square, we're going to take the square root on both sides. But if I do that, then this cancels and we have to put a plus and a minus. And we already know that the square root of 4 is going to be positive 2, y equals to positive 2, or y equals to negative 2. So you see right here we get 2 points of intersection. So these two equations intersect at the point x, which is 1, comma, y, which is 2, and x, which is 1, comma, y, which is negative 2. Now we are going to do the same thing here, but now x is going to be equal to negative 1 on this one. So negative 1 squared is positive 1 times 5. It is still going to be 5. So we get 5 plus 2y squared equals to 13. So you see that it is exactly the same thing as this. So then my solutions are basically going to be the same ones as the ones we have here. So we're going to get y equals to 2 and y equals to negative 2. We don't need to solve it again because it's exactly the same equation. So then we also get two more solutions of 2 more points of intersection. When x is equal to negative 1, y is equal to 2. So one solution is negative 1 comma 2. And right here when x is equal to negative 1, y is equal to negative 2. So negative 1 comma negative 2 would be my last solution. So these two equations intersect at these 4 points. As a summary, before I continue, just keeping the following in mind. When we solve a system of equations that are nonlinear, okay, then more than likely you're going to have solutions that will range from 0 solutions all the way to 4 solutions. That is the maximum number of solutions that we could expect in systems of nonlinear equations, so that you can keep that in mind. Next problem. Now we're going to do one similar to this at the end. So let's first of all do this one. Solve the system by the addition method. So remember that for the addition method, the first thing is that we need to make sure that both equations are aligned in the form ax plus by equals to c. And you see that the first one is like that, but the second one is not. So what we need to do to fix the second one, we're just going to switch these two over so that the x is first and then the y. So then first equation, I'm just going to rewrite it. The first equation is already fixed. X squared plus y squared equals to 16. Second equation is going to become negative 3x plus y squared equals to 16. Now they're both in the form of ax plus by equals to c. Now keep something in mind here, that we don't have a choice on this problem. I cannot say that I'm going to try to eliminate the x's. Think about the reason. The reason behind it is that I cannot combine these two because they have different powers. So even if I wanted to eliminate the x's, there is no possibility to do that in this problem because of the exponents being different. Okay? So for the addition to work, the powers must be the same in the first place in order for me to be able to eliminate either the x's or the y's. Now right here you see that the only one that has the same powers is the y squares. So those are the only ones that we can eliminate. What is the only thing we need? As you can see, both of them are positive. The only thing is that we need one of them to be negative. How do we do that? By multiplying either the top or the bottom by a negative 1. So I'm going to multiply, let's say, the bottom one by a negative 1. And that's going to give us a positive 3x. Negative 1 times y squared is negative y squared equals negative 1 times 16, which is negative 16. Then we're going to bring the second equation down right here. X squared plus y squared equals to 16. And as usual, we are going to add these two equations. So the y squares are going to cancel out. And what happens here to the x squared plus 3x? That you cannot combine it, so you're going to write it all out. X squared plus 3x equals negative 16 plus 16, which is going to give us a 0. What is the next step in the process? Since we have x squared, we need to factor in this case. We cannot use the square root property. Now, the right side, it's already a 0. So we already have it set up, so we're just going to factor. This problem that has two terms, you see that the only way to factor it is by doing the greatest common factor. And you see that both of them have an x, so we can factor out one x from these two terms. If I do that, we're going to be left with x plus 3. Then if I solve for x, x is equal to 0, and this one, x is equal to negative 3. So those are the values of x for my solutions. X is equal to 0, and x is equal to negative 3. The next thing we're going to do is substitute these two values into one of the two original equations to find the value of the y. I mean, right here, both of them are equally difficult, so you can pick whichever one in this case. I'm just going to go and use the the top one, because right here there's no simpler one. So if I substitute x with the 0 right here, we're going to get 0 squared plus y squared equals to 16, which is just y squared because 0 squared is 0. Y squared equals to 16, and to get rid of the square as usual, we're going to take the square root on both sides. So we can cancel out the square, but it has to be a plus and a minus. So the solution for this is y equals to 4, or y equals to negative 4. So then there are 2 points of intersection right here. The points of intersection are when x is equal to 0, y is equal to 4, and when x is equal to 0, y is equal to negative 4. Now we are going to do the same thing to find the values of y for this second x equals negative 3. So I'm going to replace the negative 3 into the x, so it's negative 3 squared plus y squared equals to 16. Negative 3 squared is a 9, so we get 9 plus y squared equals to 16. we subtract, we can use the square root property again because there's only y squared, so we subtract the 9 and we get y squared equals to 7. And also we're going to take the square root on both sides to get rid of the square, but we have to put a plus and a minus. And we already know that the square root of 7 cannot be simplified because 7 is prime. And square root of 7 is not a perfect square, so we're going to leave it like that. Y equals to the square root of 7 and y equals to the negative square root of 7. So I'm going to write the 2 points of intersection that we're going to get from this. When x is equal to negative 3, y is equal to the square root of 7. And when x is equal to negative 3, y is equal to the negative square root of 7. And this completes the problem. These are the 4 points of intersection of these two equations. Remember that you can always check your solutions by substituting these values into both equations and seeing if this equals to 16 and if this equals to 16 as well. Next question. Now we're going to get into the good part. We're going to solve system by the method of your choice. Now, I want you to think that on this problem, there is only one possible way of solving it. We cannot use both addition and substitution. There's only one way that actually works. And I mentioned that in the previous problem. You see that even if I wanted to eliminate the x's, I can't because the powers are not the same. If I wanted to eliminate the y's, I cannot do that because the powers are not the same. So addition is not a possible choice. So the only way that we can solve this by is by substitution. So substitution only. So you keep that in mind. This is the only way that works in this system. So step 1 that I'm going to do, I'm going to solve for x or y onto the bottom equation because the top one has squares. It is not recommended that we solve for a variable that has a square. So I'm just going to solve for either x or y on the bottom equation. So let's say x. So x plus y equals to 6. So if I move the y over, you get x is equal to negative y plus 6. Then what do? Since x is equal to negative y plus 6, we are going to substitute that expression into the x right here of that equation. So then the top equation is going to be x, whatever x is square, plus 2y square equals to 36, but the x is negative y plus 6. Then, if you remember, we have already done this before. Negative y plus 6 squared means that you have to multiply negative y plus 6 times negative y plus 6. We have to distribute it. Then plus 2y squared is equal to 36. So if I distribute these two parentheses, negative y times negative y is positive y squared. Negative y times 6 is negative 6y. Then 6 times negative y is negative 6y. And 6 times 6 is positive 36. Then we're going to add the 2y squared and equal to 36. What else can we do? Combine like terms. So for like terms, we have these two terms that can be combined. Y squared plus 2y squared is going to equal to 3y squared. Then we can also combine the negative 6y minus 6y is going to give us negative 12y or minus 12y. And then I'm going to bring the plus 36 equals to 36. To be able to factor, remember again we need to equal it to 0, so I need to subtract the 36 from both sides, but it's going to cancel on both sides. So all we're going to be left with is that 3y squared minus 12y equals to 0. Then you see that again we ended up with two terms. So we can factor with the greatest common factor again, because both of these we can factor them by a 3y. They can both be divided by 3 and by y. So we're going to take out the 3y from these two terms, and that leaves us with y minus 4 inside of the other parentheses, equal them to 0, so you get y equals to 0 for this one, and y equals to 4 for this one. So it is recommended again right here that we replace our answers into the second equation, because it is way easier to do than the first equation. So the second equation is x plus y equals to 6. So if I replace the y with the 0 right here, x plus 0 equals to 6 means x equals 6. So when x is equal to 6, y is equal to 0. So one of my solutions is the point 6, comma, and 0. Second, when x is equal to, x plus y, which is 4, equals to 6. So then I subtract 4 from both sides, and that gives me x is equal to 2. So right here, when x is equal to 2, y is equal to 4. So my second point of intersection is the point 2, comma, and 4. So that means that these two equations intersect at the points 6, comma, 0 and 2, comma, 4. We can check these solutions as usual by replacing the x and the y into this equation and this equation to see if it equals to 36 and to 6 on both. Next and last problem. We are going to solve this system by the method of your choice, again, by the substitution or the addition method. So in this problem, what would be the easiest thing? You see that both equations are in the form of ax plus by equals to c, but keep in mind that we only have one choice. If we want to use addition, addition would be the best choice for this problem. But there is only one variable that we can eliminate from these two equations, and that would be the x, because that's the only one that has the same, that has the like terms. This cannot be combined with this 9y, so that we're gonna leave them alone. So the x's are the only ones that we can cancel. So you see that they're almost ready to cancel. The only thing is that we need a negative on one of them, so I'm gonna multiply, let's say, the bottom equation by a -1, or the top, whichever. So if I multiply the bottom by a -1, we get negative x squared. -1 times negative 9y is positive 9y, equals -1 times 45 is negative 45. And then we are going to add it to this equation. We're going to add it to x squared plus y minus 4 squared equals to 81. So when I add them, the x squares cancel. 9y plus y minus 4 squared, those two cannot be combined, so we need to write them like this: 9y plus y minus 4 squared, and that is equal to negative 45 plus 81 is a 36. Then we did this already. Remember, the y minus 4 squared means that you're going to multiply y minus 4 by itself, and then you're going to add it to the 9y, and that is going to equal to 36. So let's multiply this. So we're going to get y times y, it's going to give us a y squared. Y times negative 4 is minus 4y. Then negative 4 times y is minus 4y. And negative 4 times negative 4 is plus 16. And then we're going to add it to the 9y right here, and that is equal to the 36. Now we can combine like terms again. So we can combine the 9y minus 4y minus 4y. 9 minus 4 is going to give you a 1y, so it's just going to be y. So I'm going to bring everything else down. So this is a y squared plus the 1y, and then right here you see the plus the 16. That equals to the 36. As usual, we need to equal it to 0, so I need to subtract the 36 from both sides. And I'm going to continue the problem up here. That is going to give us y squared plus y minus 20 equals to 0. 60 minus 36 is negative 20. Then we're going to factor. This one is a trinomial, so we can factor using the AC method. So 1 times 20, it's going to be 20. So we need to find two numbers that multiply to 20, and when subtracted, they give me a 1, which is going to be a 5 times 4. And it has to be a positive 5 and a negative 4, because it's a positive 1. Then y is equal to negative 5 right here, y is equal to positive 4 right here. Now to find the values of x for these intersections, we have to replace these values of y into one of the two original equations. I'm going to use the simplest one to me, which is going to be the bottom equation. So it is x squared minus 9y equals 45. I'm going to do it for both. So if I replace the y with the negative 5 right here, we're going to get x squared minus 9 times negative 5 equals to 45, which is x squared plus 45 equals to 45. Then we can use the square root property because we only have the x squared, so we can just move the 45 over, but that's going to give us a 0 on the other side. And then to get rid of the square, as usual, we're going to take the square root on both sides, plus or minus. But in this problem, since it is x equals 0, then we don't have to say x equals to positive 0, x equals negative 0. We just say x equals 0. That is only one value. Okay. So my solution for this would be that the point of intersection is when x is equal to 0, y is equal to negative 5. So 0, comma, negative 5 is one point of intersection. And to find the other one, we're going to replace the y with the 4 right here. So x squared minus 9 times 4 equals to 45. So we get x squared minus 36 equals 45. We add the 36 over to the other side. So we get x squared equals to 81. And then as usual, we're going to take the square root on both sides. And we add a plus or a minus. And the square root of 81 is going to be x equals to positive 9 or x equals to negative 9. So for that we get 2 points of intersection. So we get that when x is equal to 9, y is equal to 4, and when x is equal to negative 9, y is equal to 4. So these are my values of x for this value of y. So these two equations, then we say that they intersect at the point 0, negative 5, 9, 4, and negative 9, 4. Those will be the 3 points of intersection. And that completes this lecture 5.4.